Welcome to Meki Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement for creating these kinds of technical videos in a public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark for creating these kinds of technical videos in the public domain. And I would like to thank Almighty for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for the continuous support. Today's topic of interest is force. The force for a mechanical engineer, force is very important. Force is very important. A subject called mechanics will derives the force in the different kinds, and those force the good and bad things are discussed there. Therefore, for a mechanical engineer, the force is very important. Either a body is in motion or a rest, the force should be there. The friction is one kind of a force. It tends the moving body to static condition. Therefore, it is a negative force. If we want to accelerate a body, then we need also a force. So, the force which tends the static body to the dynamic body, then it is called as a positive force. And this force is everywhere. That is our understanding. That we have to know. The force is everywhere. If we want to move in a ground without producing any force, you can't move. So with this understanding, I will let you go to the force, and I'm going to introduce a subject called engineering mechanics. So engineering mechanics is a subject, or it's a science which deals the study of body under action of force where the body is rigid. The body is considered to be a rigid, but the force under the body under the action of force is being studied, that is called engineering mechanics. So for a mechanical engineering, to know the engineering mechanics is very important one. Therefore, this subject should give 101 percentage of importance for the mechanical engineer. Therefore, first I would like to introduce a static force and dynamic force. The static force is the force acting on a body at rest. If a body is at rest, if there is a force which brings the body is always in the rest, that is called as a static friction, static force. And dynamic force is the force acting on a body under the motion, which is called as a dynamic force. Again, the dynamics is subdivided into kinematics and kinetics, where the kinetics body is in motion under considering force, where kinematics is the body is in the motion without considering force. Here, to find the force, we need a variable called mass. Without a mass, we can't produce a force. So, mass is a variable for force. This is very good, very beautifully derived with the concept Newton's second law. And we all know that if m is equal to constant, f is directly proportional to acceleration. So this is our understanding. Even though the mass is constant, with the accelerating the mass, we can produce huge force. Say, I would like to give an example. If we are playing a cricket, a ball released from a bat will experience more force than a ball is just a throw in a catch manner. You can easily feel that What is the difference is when a body is just thrown for the catch will have an acceleration which is nearly equal to acceleration due to gravity, that is 9.81. If a body is delivered by the bat which is having an acceleration which is more than acceleration due to gravity, that is why the force is huge. Even though the mass of the ball is constant, if we increase the acceleration, if the acceleration is increased, our force is get increased. So this is the understanding, simple understanding of Newton's second law. So here it is indicated F is directly proportional to acceleration, where m is the resist motion in the body or mass. Therefore, mass into acceleration is equal to force, where mass is equal to force by acceleration. We want to know the dimensions of the force and acceleration. The mass is always denoted in kg and its fundamental dimension is m, capital M, where the force is the unit is newtons, where the dimension is fundamental dimension is ml t power minus 2, where the acceleration we know that meter per second, the dimension is L t power minus 2. Therefore 1 kg is equal to, or we can say 1 Newton is equal to 1 kg meter per second square. Therefore for kg it is m, meter it is L, and the time it is minus 2. So this is our understanding, and 1 kg we can easily derive that 1 kg is equal to Newton second square per meter. So this is the different form of the units. So either one mass, the unit of the mass is 1 kg or Newton second square per meter, both are same. Here we want to understand the types of the forces, that is, we have gone through different types of forces by action. Action of force, it is divided like that, collinear. If the system of force acting in the same line of action, it is called as a collinear forces. For an example, you can take tug of war. Tug of war, in both directions, some of the peoples will move, tend to tie the war or tie the rope in opposite direction. So the forces are acting in the same line, but the direction may differ. Or if we are trying to move a body in the direction of the body in motion, so that is also a collinear force where it is in the same direction. Next, it is a coplanar and parallel force. I am saying coplanar means it is in co-plane, it is in same plane. When I am saying these three things, you have to understand that collinear is the same line. Coplanar means it is in the same plane. Okay, when I am saying concurrent, it should meet at common point, or we can say it should meet at common point. Non-concurrent, I am saying it does not meet at same point or a constant point. And parallel forces, parallel forces means it is acting like parallel, either the same direction or in the opposite direction. So this we have to understand. This is called as a like parallel. So like parallel, this is called as an unlike parallel. Okay, unlike means on opposite direction. So with this information, I would like to continue the types of a force. If I am saying collinear force, the system of force act at the same line of action. When I am saying coplanar, the system of force acting in the same plane. Coplanar parallel, uh, the forces are acting in the same plane but parallel to each other, like an example of a simply supported beam with carrying 2 or 3 point loads. So that is the simple example of a coplanar parallel forces. Coplanar like parallel forces is the force in the same plane and the parallel to each other and the same direction. Therefore, this is an example that train track and rails are the same thing. An example, in a wagon, in a bogie, we have nearly 4 points are in contact with uh, track. That 4 point, we can easily say that it is acting in the same plane, parallel forces, all in the 4 point, all are acting in the downward direction. So the train track and a rail is a very good example of coplanar like parallel forces. Next, coplanar and concurrent. when i'm saying coplanar when I am saying coplanar, it should meet at same plane. Concurrent, it should meet at common point. Therefore, if we club these two things, the force in same plane and meet common point, that is an coplanar concurrent force. A rod resting against a wall, that is a simple example. Where the coplanar non-concurrent, coplanar means same plane, non-concurrent is does not meet at a common point. Therefore, the system of forces acting in the same plane does not meet at a common point. For an example, the ladder resting on a wall when a person is standing. So this is the typical example of coplanar non-concurrent system of forces. The next one is the non-coplanar parallel system. Non-coplanar means it won't meet at a common point. So it won't meet at a common point, but the forces are parallel. The system does not lies in the common plane and parallel to each other. So that is called non-coplanar parallel system. The classroom benches are the typical example of this. Next is a non-coplanar concurrent. Concurrent is should meet at a common point, where non-coplanar is no common plane. Okay, the system of forces does not lie in the same plane, but it meets at the same point. This is an example. The tripod camera, the camera fixing stand is called as a tripod. So in this tripod, uh, the stands are three stands are there. The three stands are meet at a common point. Therefore, it is having at the camera surface end, but the direction is differ. Next, non-coplanar non-concurrent. Non-coplanar means no same plane. Non-concurrent is does not meet at a common point. Therefore, force does not lie in the same plane, does not meet at the same point. This is an example. The force acting on a moving bus, which is called as a non-coplanar non-concurrent system. Next, the important thing is a couple. Two like, two unlike parallel forces acting on a body at which it causes the rotation is called a couple, where moment is the force into perpendicular distance is called as a moment. The next one is the two thing we have understand very much carefully. We have to understand, one is the resolution of forces and another one is the resultant of force. The resolution of the force, if a single force, if I am saying we have a x and y plane, there is a force acting in this direction. This force can be resolved by like this, vertical and horizontal, with the angle of inclination theta. Say this is the, say the force is F, the F cos theta and F sin theta. So this F cos theta and F sin theta are resolution of forces. The single force into two different force. So this is called as a resolution of force. When we say we are having two forces 90 degree to each other, say this is F1, this is F2, these two forces can be replaced by a single force which is called as a resultant force, which is nothing but the resultant force is equal to F1 square plus F2 square and the whole root. So the two forces can be converted into a single force, that is called as a resultant force. When a single force is converted into two force, that is called as a resolution of force. I hope that with this I'm going to close the force section. I hope that I have given an enough knowledge, whatever I am know, whatever I'm having, that I have given to the you, and I have transferred those knowledge to you. If you have any doubts, please let me know in the comment section. I will put another video for your doubt. Thank you all. Thank you once again.